This talk will actually be rather short and pitchy, and thanks for announcing it correctly, even though I mistyped it and figured it out today that the talk should have been qualifying Rust to the highest level of safety. But this is Rust. We can fix that by just adding a bang. And then the title actually works as a pitch talk. We should do that. So first of all, to everyone, who am I? I'm Florian. Some people know me on GitHub as Skate and on Twitter, sorry, as Zagorak. There's a typo. I'm a co-founder of the company Ferris Systems and its subsidiary Critical Section, which is there for bringing Rust to safety critical. And yes, we happen to use Rust in production. Thank you for adding me to that slide. I'm a co-founder of the RustFest conference, the OxidizeConf conference, of the Rust community team, of the Rust Berlin meetup, and also of the Rust Foundation, though I stepped back from a lot of these things. I co-founded them, but currently, actually the thing that I'm talking about is the only thing that I'm actually currently working on as part of my business. And so let's start with a downer. This is a picture of all the commercial planes flying around this globe using Rust that I am aware of. Exactly 0. And I think that's great. And I'm going to tell you why. So why should we have Rust in avionics? Or also in all the other safety critical departments? Without going too much into detail, during one conversation with someone from that space, there was an interest, and I think that's a great, they framed their interest, and I think that's a great feedback to the community as like Rust is kind of the sea of change. So around Rust, it's not only the programming language, but it's also different practices, very open source practices, an open source project that runs a considerable CI, CD, and QA operation as part of the project. So everything that comes downstream needs to work by the same quality. And Rust is modern, fresh, but also inspired by the values of languages common in the avionics space. It's rarely listed as such, but Rust actually is, and I know that from some of the people who've designed it, also inspired very much by the correctness principles that Ada has. And one problem that is coming up in all the safety critical industries nowadays is higher software churn meets software writing in higher assurances languages. We can't spend years and years validating a piece of code. We'll probably spend years and years validating larger pieces of code, but the change patterns are increasing everywhere. And it suits the problem space well, matching important standards in code and procedures. And that's like actually the one aspect where I would actually like to talk a little bit about how those standards work, because there's a lot of misunderstandings there. Standards in general, without making, I could give a whole series of talks about this, but these kind of standards that we're often talking about in safety critical are coming down as to a simple principle. They make certain they make certain requirements, and it's actually up to you to figure out how you meet those requirements and give a good argument on how you met them. And they're strict in the sense of you need to do this. They're actually rather liberal in the sense of how, as long as you can address that. And I would like you to give you a little bit of insight into one of those standards, particularly here. This one is DO 178C, the newest version of the avionics standard. And there's the thing that people always say is like, no one uses the heap in these kinds of systems. That's actually not true. The current standard does actually include rules or particular risks that need to be addressed if you do heap allocation, if you use dynamic memory. And this is a paraphrased version here for easy accessibility. And it's also not the full version, because then this would be a talk of going through a number of risks. But here's a couple of things that, for example, memory allocation needs to address, which is straight from that standard. The first one is we need to talk, and we need to make sure that there's no ambiguous references. Like, for example, a memory allocator returns a reference to a valid piece of memory, not otherwise in use. The other risk is deallocation starvation. An allocation cannot fail because of insufficient reclamation of inaccessible memory. That's basically you're leaking memory until you're running out of memory. That's a classic memory leak. Premature deallocation. An object is only deallocated after it is no longer used, so that you have no illegal accesses later. Lost updates or stale references. If the memory management system moves objects to avoid fragmentation, we see the word move there, so we see where it's going. Avoid fragmentation, inconsistent references are prevented. And a third one, time-bound allocation or deallocation. So allocations and deallocations need to complete in a bounded time. So usually a predictable time. That is, for example, a risk that you run into when you're using a garbage collector that may delay deallocation to a certain point, and then you might break this time bound. And Rust addresses this. Rust borrowing bans ambiguous references. Rust ownership makes leaking memory hard. So this is only a mitigation. You could still leak. It makes it hard. Rust ownership does not allow premature deallocation. Once the type's gone, is gone. You're not allowed to access it anymore. This is particularly the point with moving out. Rust ownership only allows moves while data is not being referenced. And that, for example, makes sure that these kind of moves where references need to be updated don't happen, because references are not allowed to be given out while you're actually moving stuff. So the language bans this. And Rust allows for time-bounded deallocation. I could still use a memory allocator that does, for example, the things that I just explained, like delaying deallocation, but the language doesn't mandate it, and it is the norm that those allocators don't behave like this. So just as a little bit as a connection on how Rust is actually fitting the space, because I see a lot of arguments, particularly there's a lot of naysayers, and they prefer to make arguments why Rust doesn't fit the space. It's much more interesting to talk about trying to come up with arguments and why it does fit it. And the thing is, we are very much at the beginning, and I said I think it's exciting. So here's the space of Rust in avionics, and I took an empty circle for a reason, because it's literally empty. But we're at the edge of it, not away, not in it, but we're at the edge of it. And that means this is a huge chance for anyone who's interested to go into that space and say, I've got an opinion how libraries should look like. I have an opinion how engineering standards around a programming language should look like. I want to talk about new approaches. And particularly for everyone who wants to go into this space, that also means new experts. Now is the moment where everyone has exactly zero experience on how to actually do industrial engineering in that space. And if you're interested in that space, it is your moment to go into that space and say, in 5 years, I'm the Rust expert for how to fly a plane with that. And that is something that I've commonly seen in a lot of areas, because the IT industry is actually refreshing a lot. People that move, like that switch the space at the beginning of this, can become notable experts very quickly. So that is, as I said, also a chance and an exciting time. So we are at the beginning, exactly at, not before, but we're also not after. And I can share today, I had I had 2 emails and a discussion around precisely that thing. The problem, and I'll come to that, why that is a problem, is that I can only be vague about this. But what I can share is, if you look at conferences in that space and look at the papers lists, Rust is discussed, and those papers recommend the language. We as a company are getting regular requests and are close to closing contracts. Automotive Rust is generally well on the way. There's much more effort there, and also much more companies being open and hiring Rust programmers in that space. And I've already heard let's not let them set the standard. So let's make sure that this industry, like the avionics industry, also is at the table when setting the standards. And the question that I have is, given that a lot of base libraries aren't built, isn't that also a chance to start right at the top and say, if we're talking about the very fundamentals, everything that comes on top of libcore and including libcore, why not start with the very highest assurance levels and the very highest quality levels at this phase? Because one of the things is, in general, if you have a library that's fit for avionics, it's fit for any other of the high assurance standards as well. Sometimes they may ask for other activities, but usually you can make an argument why that is safe for that. So where are the gaps? One big problem and one success piece of Rust is that it always connected to environments where it can travel together with. High assurance routers, Tokyo. Like Tokyo is the library for sending packages from A to B. And that may sound simple, but that's a fundamental problem of the internet. And making that safer, faster, and more reliable has been a huge boost. So picking actually communities that are already in that space and collaborate rather than making that a fight is important. And then a lot of legwork. Libraries, and in the high assurance space, also tools. Testing tools, coverage tools, things like stack depth detection, and making sure that, that we know how much memory we use, and that we safely can assess how much memory a Rust program uses. All of these things are missing, at least at the quality that those industry needs. Software engineering practices and documents, review guidelines. That's another big hole. There's actually no good review guideline out there for unsafe code that you can hand to a review engineer. You can go to the unsafe coding guidelines repo at rustlang/rust, but that's for people who are trying to figure out like what unsafe even is and what the exact rules around this is. There's no tangible checklist on how to review unsafe. Standard development procedures. There's in that space that usually needs to be documented, like what are the standard development procedures? And training. We have that as a company. One of our biggest businesses is actual training, but that also means training for safety critical efforts. And as some of you know, I also have a bridge to sell. I'm part of a project that builds a high assurance Rust compiler. This one is called Ferrocene. Since the beginning of the year, Ferrocene is actually a joint venture between Ferrous Systems and AdaCore, the company behind the most notable Ada compiler. You can read all the details on our blog about this. Without boring you there, I would like to give a little bit of insight of what that actually is. So it's a joint venture between Ferrous Systems and AdaCore, and it is not a new Rust compiler. That's the biggest question that a lot of people have. It's a downstream of rustlang/rust. It's currently closed source and could very well remain that, but mainly because it implements, for example, support for targets not supported by upstream Rust-C, and that becomes a licensing concern. But it is with all intents and purposes, a downstream. So if you don't need that support, you can use upstream Rust-C. It runs a little bit higher test coverage on those relevant platforms and does automated testing, for example, for platforms that upstream Rust-C doesn't have, and it has a different configuration. So the compiler is actually a little bit slower at the gain of being a little bit more correct, which is, well, for those who are paranoid, for good reasons, because lives are at stake. It will provide from the beginning of next year, roughly, regular releases qualified for industry standards, currently aiming for ISO 26262 ASIL-D, which is automotive, and very long-term support, because that's also needed. A plane or a car might be in use for multiple decades, and the software might not be updated if it's not broken. If you find breakage, you want someone to give support. So this is not talking about like general long-term support for Rust itself. This is for the customers that need the very, very long one. But also a set of tools that we're going to slowly build around it for crucial analysis, certain kinds of coverages that are required by those standards, stack depth analysis, and all of the things that I mentioned, and also the documentation required by those standards, because this code review document that I was hinting at suddenly is not optional anymore. You need to present that. You need to tell people how to use the tool properly. And also in the future, well, libraries for use in safety, functional safety settings. And I'm currently trying to figure out how I think it would be very beneficial if those would be open source and openly usable, particularly, well, because open source, and that's an often forgotten thing, also means accessibility of the space to newcomers. I think it's completely, but I think it's a strength that any person sitting in their living room saying, I would really like to know how this field of our industry works, and being able to have a look at a library, say, okay, let's play around with this and see how it's being built. There's also an education component in that. I have definitely benefited from that a lot. So you can read all the details up on our company side. So what Florian and Rust need as a end? First of all, engineers interested in bringing a new programming language to a new space. That's still a long game in the sense of we're not done in a couple of months. We're done in more a year or more, and the endeavor will probably take the next years. So just to be clear, yes, we're hiring on that on very specific posts because this is a very special work. So this is actually very interest-driven. If one is really interested in the really, really small details on how a programming language or compiler works, that's a post for you. Investors and departments interested in trying out a new horse, and investors and departments interested in technology readiness endeavors. If you're working at such a company, this is one of the things that people often aren't aware. There's probably one section of a larger company that is specifically there for bringing unusable technology, like by those standards, into usable state. That's usually called technology readiness. And like beating the drum at their places for, that doesn't only have to be the first scene, but also for everyone else who wants to build a library in that space or something like that. So, and just to be clear, all of that costs hard cash, and this industry will only exist once people start investing into it. And how do we make that happen? By building the understanding for managers and also for any kind of future thinking part of companies that it's not time to get serious, but it's already serious. There are already companies getting ready to invest in that space. And if one wants to be at the forefront, now is the moment, and not the moment where things pop up. Because this is the last thing. If you know about anything and you can speak about it, speak about it. Go to a meetup, talk about it. Because one of the problems that we frequently discover is that thing that I hinted at before is like, so who's using Rust? And my problem is I know a lot about where people are using Rust, and I sometimes joke about it that a lot of the announcements that I see out in the open, like the AutoSAR announcement a week ago, I knew about that month ago. And I would have preferred that before making a big splash, they would have at least like talked about it at relevant meetups, at relevant Rust meetups, and all of these kind of things, so that people are at least aware that something is moving. I think that this setting of only talking about things that are done is really, really harmful to especially new technologies, because then if you talk about unfinished things, and if you encourage the company you're in about by being open about, yes, we're investigating Rust, and that's okay as a statement. I mean, that isn't even commitment. You can still say 2 years down the road, we've investigated Rust and it didn't fit for us and we're using something else, be it Zig, Swift, D, whatever, I don't care. But having talked about it means that this opens up the space for a conversation, also for other companies in the space saying, hey, how has that worked for you? We need some exchange. Everyone going alone will not build an ecosystem. Particularly, you've heard the first talk and how important it is to build a community. So being more liberal, at least talking about the things that are going on will be really, really beneficial there, because that also makes it easier for insecure players around the space that do actually want to have a signal of, okay, there's at least a couple of other companies roughly around our circles that are actually using Rust is incredibly important. And that's basically my point. If we want to see Rust in avionics, we need to talk about it, and we need to talk about every aspect about it, and we need to talk on RustFest, we need to talk on RustConf, we need to talk on all of those conferences, and try to encourage everyone who actually has a tangible thing or who has a plane flying to talk about, hey, by the way, this plane flies with Rust. So, questions, opinions, ideas, and leads if we still have time, or anything else?
Yeah, we have time. We've got time for it.
Thank you.
Thank you very much. Any questions?
Hi, Florian. This is Andy Thomason. I occasionally work for Ferris. So yeah, it's a very, very interesting project. And very nice to see Rust in this space. Ada has kind of dominated this space for a very long time. My previous boss, Con, is kind of famous for a piece of avionics software he wrote. This particular avionics piece of software threw an exception, resulting in Ariane 5 blowing up and showering the local countryside with flaming bits of rocket. But that software was thoroughly tested. How would Rust sort of improve on the sort of problems we have with, there are obvious problems with Ada. How does Ferrocene improve on the existing safety standards that Rust already has?
Okay, so that's actually a good question. Because my answer to that was, I sure they wish Spark had existed, which is the formally verified subset of Ada. My position, and that's a question we get a lot, is like, particularly because of our now relationship with Ada Core, is like, what does that mean for Ada? And my position there is more, how do we make sure that we move beyond memory unsafe languages and pretty lenient languages? And so I see less of a collision with Ada there. With Rust, I see a great opportunity that there's a curious convergence in that if you, for example, see who's running around at the formal verification interest group, a lot of these companies actually are not from the industries where you would usually see formal verification being used, like, for example, cloud providers and all of these kind of things. And the testbed for all of these things is Rust. So this is less about the properties. There's reasons why they have picked Rust for all of these endeavors, but also like kind of the social circle around it, that there's a huge amount of work currently being done on making Rust even safer and more structured, or finding, for example, how we can constrain unsafe code to be safer. Finding all of these things out is my main argument why it is useful. Things like the Ariana will still happen with Rust. I say, like this, there's always the element that something hasn't been observed, and I think it's also important to be honest about this. This won't fix everything, and you can also share like the work on the memory allocation part actually comes out of I pulled that out of an example that I worked together with the Spark team on, because Spark now also has an ownership model that actually works on pointers. So it actually has strong points where Rust actually has weak points. Rust pointers are okay. All bets are off. So there's a curious and interesting thing going on in my head about what would actually be an ecosystem that where Ada and Rust combined. What would that look like, rather than always seeing like C and C++ as the foreign language? Yeah, long answers.
A couple more questions. Luca was here.
Yeah, Luca here, Florian. So you touched upon before that, of course, we are at the edge of the space, and you want to get people that are keen on bringing a new language to new environments. And like, based on my previous experience in different ecosystems, that usually requires convergence on both sides, where you want some people that know the language but don't necessarily know the environment, and some people that know the environment but don't necessarily know the language. And that's usually a lot easier if you have gateway drugs into the ecosystem. One, you can experiment in the thing that is not actually the real thing, so you don't have necessarily the pressure of like doing it right, but you can get people in the ecosystem you wanna, I wouldn't say conquer is the wrong word, you actually want to enter into, that actually try it out. So for example, in clouds, a lot of that is CI tooling, CLIs, builds, and so on and so forth. So my question is, what is that for avionics? Is it flight simulator? Is it different types of software? How do you get avionics to play with Rust without doing the real deal the first time?
Actually, in avionics, I'm not quite sure yet what I agree with all you said. Just to be clear, I think that's a very useful thing to find out what that would be in avionics. This is actually a little bit of a problem that I have in that the gap in this industry is actually quite high, and I think it could be drones or something like a simulator. I could maybe take an example from another industry. There's a company in Saarbrücken called Gilcher who are building a framework to prototype cars with, and they are particularly thinking about that, like how can we simulate like the real environment of working on a car without actually having a car in that sense. One of the things that I'm seeing as a general drift is that a lot of things are moving towards simulating. A lot of hardware is working towards simulating somewhere in the cloud or something like that. And I could also see that maybe something like that may give people the ability to play out. The other thing I see AeroRust as particularly like a space where that could happen, because it's particularly focused on that and is open to people from both sides. So yeah, but I think it's an open question. It's an important one to think about.
Great. Next question.
Hi, Florian. David Haig here. I've got two questions because I'm greedy. One of them is you mentioned ferrocene is below. It doesn't replace Rust C. Does that mean it replaces LLVM or something like that? So that's the first question. And then the second one is about the comments about bringing Rust into the Linux kernel and how they have a big problem with panics. And does ferrocene have some way to make that go away with fallible, just a different way of doing things, so that you can write much more explicit stuff, so you can't reference, so you can't panic if you mess up a slice or something like that with an index? That's me.
Okay. So the first question first. Ferrocene is in general a downstream of Rust C, and we do not replace anything. The biggest problem in compiler qualification, particularly like tool qualification, is more a practice in automotive than in avionics, but the activities are roughly the same. The biggest problem is you need to present a structured understanding of what the tool does on the platform that you're deploying it. So rather, Rust C goes, we'll support everything under the sun as long as there's a maintainer for it. Just be aware that one of the targets might not be of sufficiently high quality for production use. The project indicates that by that tier list. Now, imagine you want to use Rust on a car with a very specific hardware, with a very specific closed source operating system. So what you need is you need a supplier that says, this is Rust C, it has a target for this car, and this is thoroughly tested every night. And if there's any kind of bugs, and that's the other part here, is there's any kinds of bugs, we need to present as a company that we are willing to immediately indicate to our customers that there may be a crucial bug and that they should check their deployed software. So a lot of that qualification is actually a qualification of the organization and our willingness to be very candid about all bugs. This is something that people often oversee. That being said, we are looking at things like also supplying Rust front ends to other backends. And there's a lot of tool chains around there, and we're trying to navigate that space. The reason why I'm not willing to talk openly about this yet is because none none of those deals are fully done yet. So there's a wide variety around that. And yeah, so in the end, the service that you get is on this very specific configuration that we're using. We have made sure that everything has been done to make sure that we are reasonably aware of what the compiler has. So some of the things are even, we have a list of bugs. We know it has bugs, but here's a list of bugs, and this is how you prevent hitting them, is also a huge part of that practice. So that's the one question. I hope that was sufficiently clear. But it is actually, just to be clear on that, it is actually intentional that we do not want to diverge from Rust-C, particularly for the reason that, for example, say your target is ARM, which is pretty popular here, and you want to get started. It is fair to just get started with the open source one and replace it by Ferrocene once you have the assurances, and making that easy, I think, is to benefit of everyone. Okay. The second bit about the panic and Rust in Linux. The Rust in Linux initiative is pretty interesting because it's also already full steam ahead, and I can share that the email that Linus Torvalds wrote for most of the people who have been on the core team back then and engaged in these kinds of endeavors was, okay, that's the same problems that we also see. That's generally a good sign. That wasn't surprising. For all of the things that are needed, there's solutions, and the question is how okay you are with a hacky solution. So for example, for panics, the way to figure out whether your Rust code can't panic is actually checking if the panic symbol is linked. There's tools for that. It's really annoying though. This is not very convenient, and this is a very hacky way that may not work if, for example, someone changed the panic symbol or implemented another way of throwing exceptions or whatever. And so providing tooling, particularly around that, to make it easier to write panic-free code, make panic-free code a first-class citizen of the language. That could be, for example, something that I can see as contributions out of this project. The same goes for other things, like, for example, a huge criticism that also comes from Rust and Linux, but also other places, is that libcore's management strategy currently is, if it doesn't use the heap, we can put it in libcore. But an ECU, so an engine control unit on a card, doesn't need a UDF-8 implementation, which comes with the string, implementation, because your brake probably doesn't, or your engine probably doesn't use UDF-8 internally. And given that we need to look at all bits of code that we put on those microcontrollers or on those controllers, needs to be thoroughly vetted. That's a liability. So, for example, also looking for things on how, for example, is it possible to factor out, for example, a libmini core that most people wouldn't use, but that is easier for these kind of safety critical environments. All of these things are, just to be clear, very rough thoughts that I've spoken to a couple of people about, but that come out of this work. Like, we have an assessment document on how hard it is, for example, to ship a certified libcore and things like that. Also for people who've never engaged in such things, just as a bit of a feeling, the cost of qualifying the compiler and the cost of certifying libcore, so to make sure that libcore is actually allowed to run somewhere, is libcore is more expensive, because that actually ends up in the system. The compiler does not end up on the system, so it does. It is only a tangential bit. But that also means that there's interest from multiple sides to get all of these problems addressed, and there's a curious overlap also between Rust and Linux and these kinds of concerns.
Great, thank you very much, Florian.